if you feel you need to. If you don't understand this, you may want to look it over. Here is what is happening here. What is negative 2 squared? Positive 4, yes? Because that negative is part of the base, so this is really negative 2 times negative 2, correct? Okay. What is 2 squared? 4. If negative 2 squared equals 4 and 2 squared equals 4, then what does that tell us about negative 2 squared and 2 squared? That they are also equal. Does everybody follow this logic? That is why this negative g to the 6th is the same as positive g to the 6th. Because the negative is part of the base and the exponent is even. Is everybody cool with that? That is also why negative s to the 12th is the same as positive s to the 12th. Good? Yes? What if the exponent is odd? Are you allowed to do that? No, because negative s to the 3rd would be negative, right? Everybody good? Okay, that is a big problem for you guys. So if you don't understand that, you may want to write it down. The next big problem for you guys, and again, you may want to write this down, you may not. The next big problem for you guys is this. What is 3 to the negative 2? Is that allowed? No. No negative exponents. So this becomes 1 over 3 to the positive 2, yes? Which is what? 1/9, yes? Cool? Okay. What then is this? Negative 3 to the negative 2. One over negative 9 is acceptable because the negative is not part of the base. What is this? One over positive 9, because in this case the negative is part of the base. Is everybody good there? Yeah? Okay. And then one last wrinkle that I'm adding to this. Please notice that none of this is new laws, are they? It's just interpreting the laws you already know. What about this one? X to the negative 2. No, not that. Not yet. No. X to the 2 to the negative 2. What would that be? One over x to the 4th. Everybody cool with y? The negative exponent moves down there. That becomes positive. Yes? Everybody cool? Okay. Then what about this? What? It is just x to the 4th. Now Sam, I'm guessing because he got it right away, simply remembered this law, right? Which is negative times a negative, right? To get positive. But what is really happening there is this is going to become 1 over x negative 2 to the positive 2. When that moves down to the denominator, only the outer exponent changes. So then you would do this, and you would have 1 over x to the negative 4. Negative exponents aren't allowed. Since he's in the denominator already, we would bring him back. That's about the hardest thing you can do with exponents right now. Is everybody okay with everything I put down the margin there? That's as far as you could possibly take the exponent laws right now. And after today, after we've gone over this sheet, we're going to take a step back from exponents. Because as you can see, even though the rules, there's only 7 of them, they can get tangled up with each other. Yes? So we're going to take a step back from them, do some other stuff with exponents, get used to using them, and then we're going to go back and do some more tangled up exponent problems. Okay? All right. Now, I also am well aware we have not gone over your trig test yet because one more person and 2 people need to write it. Okay? So, but I want to do the trig cumulative on Thursday. So what I'm actually going to do with you 2 is send you to write it right now. Grab your calculator, Jack. Grab your calculator, James. Because we're going to be spending some time on this, and then I'm going to go over this, so that should give you enough time to get it done. No. What? Yes. Let's go. Grab your calculators. Nice job. Who's Carlos number 1? Okay. You gonna stand for that, Carlos? He says he's Carlos number 1. You happy with that? You want to be number 2? No. You gotta fight for it. Yeah. Exactly. Yeah. No, that's not a problem. Right. Sarah. Lexi's way over there. I'll drop Ethan's off we need. What? Did you hand it in? I did mark it. I seem to remember. Michael, here's yours. I definitely remember marking it, Brianna, because I remember putting it in to check my marks. Oh, I got it right here. Brianna. Okay. Okay, we need to go over a couple of these questions, please. But I want to stop these answers.
Jack and James, we have just gone over the test that you just marked.
Just wrote. These are the rest of the marks. You can check your exponent stuff against this. Nobody needs to talk about any of those. Brianna, then you. Number 4I, okay?
Yeah, it is e squared f negative 4 and g negative 10.
Okay, so it's a little bit hard to read, I am sure, but I'm going to write out what this should say, and maybe it's just the printing that got you. This should be e to the negative 4 over e to the negative 6, f to the 5 over f to the negative 9, and g to the negative 8 over g squared. Negative 4 minus 6 is positive 2. Yes? Okay. 5 minus 9 is positive 14. Negative 8 minus 2 is negative 10. So I ended up with g to the negative 10, which is why it had to go down. Cool? Ish, were you asking about the same one? Lovely. I love it when I can answer two questions with one answer. To quote a horrible saying, I can kill two birds with one stone. I don't like that saying.
Why?
Because I don't like to kill birds. I know. Don't get me wrong. It's not like I don't eat chicken. I don't want to kill the animal. Personally. I'm a selfish person. I am willing to eat animals killed by other people. Yes, it is selfish. Yes, it is selfish. Because if I really wanted to eat it, TJ, I should get over my, ew, I don't want to kill it, just because it tastes good. Right? No. I should go on Survivor because A, I would get skinny. B, I would get famous because even if I didn't win, everyone's like, holy crap, do you see that math teacher on Survivor? He was a riot.
How many councils do you think you make it through?
I've never even watched one episode. I have no idea what you mean. I really don't. Oh, that's the other thing. I would win every immunity challenge, so it wouldn't matter. Because I'm smarter, faster, better looking. What? You, huh? Yes, please. Yes. I'm better looking?
That's what I heard. I'm faster, I'm smarter, better looking. I don't know.
No, I'm jealous of Mr. Federley. His hair isn't as gray as mine. All right, everyone's good? All right, next page. Sim sim salabim, magic. There it is. This page always causes problems, so please make sure you have done it correctly. You throwing stuff around, Sam? We don't like you when you're angry? You going Hulk on us? Canadians can't go in Survivor.
Can we go citizen? That's it. I was going to say civilian.
Canadians can't go on Survivor. They can't go on Amazing Race. They can't go on.
What about Amazing Race Canada?
They can go on Amazing Race Canada, but Amazing Race Canada sucks. Although I hear the second one, they actually went all over the world.
They've been going all over the world since the second one.
Yeah, the second one. The first one was just in Canada.
Yeah. Now they
What?
like to take time and
Of course I can explain number 5 to you, but
why are they all different now? Like
11C, yes.
11
Okay, so in 11C, numbers go with numbers. What's 4 times 6? 24. Letters go with letters. M4, M8 is M to the 12th, yes? N2, N4 is N to the 6th, yes? Over -3, M6, N6, yes? Now, numbers with numbers. What's 24 divided by -3? -8. M12 and M6. 12 minus 6 is M to the 6th. 6 minus 6? 0, which is 1, so it's gone. -8 M to the 6th. That's what's left. I'll get to that right now. So F is a problem for you guys because of that exponent out there. What is the base there? What's the base, Sam? Is 5 part of the base? So does 5 get squared? Yes. 25 x to the 4th y squared. And does that 3 get cubed? Yes, so it's 27 x to the 6th y to the 12th. 25 times 27 is 675, x to the 10th, y to the 14th. Okay? Okay. Any other questions from that page? Once. Twice. Thrice. Same guy that's wearing a tie every day. Me. You go ahead and wear a tie tomorrow, TJ. I think we should class this joint up a little. A bar. Put in a big gulp machine for you guys?
Yes.
All right. Okay. So we are apparently done with exponents for now. Please turn your page over to 85. Now, the title of this page, Real Number System. Why is it called the real number system? You're exactly right. Because the real number system is our system of counting. But it's called the real number system because there's another whole system. Exactly. Of imaginary numbers. No, not like DERF.
What about the fact that
The imaginary numbers are nothing that you need to concern yourself with. But they are things like this, the square root of negative 4. You have always been taught that it doesn't exist. It doesn't. But in order to do very high-level math, mathematicians have invented this system of imaginary numbers. You need not worry about it until second year calculus at university. If you're going to become an engineer or a theoretical physicist or something like that, if you are not going to do those things, you needn't ever worry about the fact that there's a whole system of numbers that only exist in the imagination of mathematicians. So forget about them. But we still have to call the regular numbers the real numbers. We will start with the natural numbers. The natural numbers are what I like to call counting numbers. When you walked into kindergarten with Mrs. Bad Crumble running the show. No. And Mrs. Bad Crumble said, all right, class, let's count how many. Let's count as far as we can. And she went like this. And you all went, 1, 2, 3. And since my wife teaches kindergarten right now, 3 is about when it ends. For most kids. Not a word of a lie. So, the counting numbers. 1, 2, 3. And how far do you think they go? Forever. They go up to infinity. No, there is no beyond infinity. That's why that line is funny. Okay? Everybody cool with that? All right. The next word you need to know is whole numbers. Now, you guys already think you know what a whole number is, right? What is a whole number? 1 is a whole number. Absolutely right. 0 is a whole number. Absolutely right. 7 is a whole number. Absolutely right.
69.
Another whole number. Another whole number. Anything without a decimal. Okay, so -8. -8. Wrong. Because you have been taught whole numbers as being not fractions, right? But that's not actually what they are. Whole numbers are all the natural numbers plus 0. So the whole numbers go from 0, 1, 2, 3, up to what? Infinity. So how much bigger is the whole number set compared to natural numbers?
1.
1 number bigger. 0. Got it? Okay. Third thing. Integers. Integers, you guys are smart kids. If whole numbers include natural numbers, do integers include whole numbers?
Yes.
And then do integers also include naturals? Yes. Integers are all, I wanted to do a different color because I used black and red. Integers are all of the above plus negatives. So it's negative infinity, -2, -1, 0, 1, 2, up to positive infinity. Everybody cool to there? Yeah? Easy peasy, right? Thank you, Jack. Now be nimble, sit down, and grab out your book. See what I did there? Okay, now we get to the weird stuff. Rational numbers.
All of the above plus fraction.
No, not quite. Yes, it is all of the above. And yes, it does include fractions, but it also includes decimals that are special. So, once again, it's all of the above plus decimals. And I want you to put a little asterisk by decimals and fractions. Now the fractions are special. The fractions have to look like this. X over y, so some number over another number, and X and Y are integers, and Y can't equal 0. If you can write a number like that, it's a rational number. Everybody cool? So let me ask you this. If that's the rule, why is 101 a rational number? X and Y, yeah. I don't know what's going on with the pen. It's not working as well as it usually does. Surprise, surprise. Why is that a rational number? It's not written in this form. Or is it? It's really over 1, isn't it? So it is in that form. Everybody cool? All right, now, remember I said there was something special about the decimals. The decimals must end or repeat. What do I mean by that? Well, if I gave you 1 over 2, how would you turn that into a decimal? Divide. And what happens when you do 1 divided by 2 on your calculator? 0.5. Decimal ends. I'll get to pi in a minute. Decimal ends, right? Easy peasy lemon squeezy. What is 1/3? 0.3333 forever. Repeats. Everybody cool? If it does one of those two things, it's a rational number. Good? Excellent. Now we get to what Sam was just talking about. All of these guys are related. Rational, integer. Now we get to the guys that don't fit in anywhere. These are irrational numbers. These are numbers which don't fit. So their decimals go on forever, like pi. Right? 3.14159, blah. And there's a lot of these on your calculator if you were to look closely. If you look close to your calculator, you'll see a little e with an x by it. That's another irrational number. It goes on forever. There's a million of them. But the important ones for us are non-perfect squares. So what is the square root of 2? 1 times 1 is 2? There isn't a square root of 2, but what happens to your calculator if you push square root 2? It gives you an answer. No, it doesn't. 1.414 blah. And your whole calculator screen fills up, right? Does it repeat? Does it repeat? No. Does it end? Only because your calculator screen ends, right? So all of these are irrational numbers. Is the square root of 3 irrational? Yeah, 1.73 blah. Blah. Is the square root of 4 irrational? No, because what's the square root of 4? 2. Everybody got it? See if I can fool you with something. What is the square root of 1/4? Is that irrational? Don't go to your calculator, use your head. It's rational, right? Why? Because it's 1/2, and that's a fraction. Sure. 4 is rational. Yeah.
Okay.
Everybody cool? Yeah? All right. Turn the page over. Let's do a bit of work, old school work from grade 6. Make that a fraction. It should take about 5 seconds. No. No. Just do the first one. Just A. What is it? Yes. It is 12 100ths. Now, stop. Would Mrs. Bad Crumble be happy with that answer? Why? She wants it simplified to what? 6 over 50, which she wants simplified again. Everybody cool? Excellent. Good job, people. Now, let's move to the next one. The next one's weird. What does that little line mean? So what is this? It's 0.1111 for how long? Ever. 1 forever and ever and ever. Yes? If there was no line over that, it would be 0.1, yes? Which would equal 1/10, yes? All right, now, does this repeat? Yes. Is 0.11111111 slightly bigger or slightly smaller than 1/10? Slightly bigger, yes? Which means the fraction must be 1 over something. It can't be over 10 because that would be 1/10. And it has to be an integer. What are the integers right near 10? 11 and 9. Which one makes a slightly bigger fraction? 1/11th or 1/9th? 1/9. So this is 1/9. You guys are very smart young people. Correct? This is 2, 2, 2, 2, 2, 2, 2. What do those 3 dots mean? That it continues. We assume it continues repeating in that pattern. So this is the same as 0.1 repeating. Well, if 0.1 repeating was 1 over 9, what's 0.2 repeating? 0.1, 1 became the denominator, or the numerator. 0.2, 2 over what? 9. Because when we repeat, we got to go over 9. Now you guys are extra smart kids. What if I add this? 0.34 and the 3/4 repeated? What would it be? 34 over 99, right? Does that make sense? Okay. What if I add 0.123, all repeating? Is everybody okay? Because of what we just proved here. Because 0.1 would have to be 1/10, right? And as a fraction, it has to be an integer and an integer, right? And 0.11111 forever is very slightly bigger than 0.1, yes? So to keep them integers, I need the integer that's closest to 10 that is slightly bigger as a fraction, which is 1/9. It's always going to be a 9 if there's repeating. Now, what is weird about D? Only the 4 repeats. I have 2 digits here, so I must be over 9 at least once, yes? Does the 5 repeat? Is there any other repeating numbers? No, only the 4 repeats. What number in our system shows nothing? 0. So 9, there's 1 repeater, and then there isn't another one. Everybody cool with that? Now, what do you think goes on the top? Let's try it. Let's go to our calculator. On. 54 divided by 90. Darn. Can't be 54. Let's think about it. You can try, we could do guess and check, couldn't we? Should we go up or down from 54? Down? Okay, so what would be the next one? 53 over 90. Check it. Does it work? Sure. Okay, what's next? 52 over 90. Did it work? 51 over 90. Nope. We can skip 50 over 90 because that's 5 over 9. We know that's a fraction. What's next?
49.
Try 49 over 90. Did it work? So we know this is 49 over 90. Now, please look. I got 54. And I got 49. And what do I got right there? Is there a relationship between 54, 5, and 49? What is it? Subtraction. Isn't this 54 minus 5? The whole thing minus what didn't repeat? So let's try another one. Let's keep 123, but instead of 123, it's going to be 0.1, 2, and only the 3 repeats. What would that be? What would be on the bottom? 900, because I need 3, and only one thing repeats. And what would be on the top? 111. Why? Because 123 minus the part that doesn't repeat. Everybody got it? That's your lesson for today. Listen to me carefully. You're going to finish this page. If you can't remember how to do these with your calculator when it's a cube root, leave it blank. But I don't need numbers here. I only need what category it fits into. Is it a whole number? Is it irrational? Is it whatever? That's the rest of this page, 86. Then you're going to do 87, which is more of the same stuff. And that's your work for the day. Okay? What's happening Thursday? Cumulative test. What is being tested? Measurement, trigonometry. Everybody Gouda? Everybody Gouda? Great. Now listen, please. Listen, please. Listen, please, so I can stop talking, so you can get back to talking about not math, because that's all you want to do anyway. I have a dentist appointment. I am leaving at 2:20-ish instead of almost 2:30. Mr. Keeley's going to come up here so you guys don't destroy the place. Make sure you put your chairs up. Right? Finish this for homework. Jack and James, I will mark these tests. It will take me 10 seconds. I will mark them right now. We can go over them tomorrow. Yeah, tomorrow. Cool? Okay, carry on, my wayward sons. There will be peace when